Thank you. Hello, everyone. Oh, man, I'm so excited to be here. It's a very cool place. I was a little embarrassed trying to get in, like parked, and then I went around and I went to every entrance and they're all locked. And I went around every side and like I can't even get into this place. And I just went around again, and then this time there was a big entrance and I was like, what? It's like when you're putting a USB stick in and like it doesn't work and you're like, oh, I'll turn it around, and you put it in and it doesn't work and you're like, let me turn it around again, and it works that time. I don't understand. Does that not happen to you people? Yeah. How? I don't understand. So I'm here to learn about the awesome robot VJ. So that was super cool. I'm really excited to use that at my house. And also I'm here to share a project that I've been working on called PoisonTap. It's a really cool, it's really fun. It uses a Raspberry Pi Zero. Who here has played with Raspberry Pis in general? All right, cool, maybe half, that's awesome. Raspberry Pis are really great. I mean, one thing that I would love to stress, I started out learning software. I learned software when I was younger. And for many, many years, I was afraid to get into hardware because it had hard in the name, for one, right? I picked up an electronics book and I read the first chapter and it's about resistors, and I read the second chapter, it's about like capacitors. I didn't understand any of it. I read the third chapter, it's about diodes. None of it made any sense and seemed absolutely useless. And when you're doing software, you like go to a page, or at least what I did was I would just steal some code and it worked, and then I'd modify it. And sometimes it also worked, right? And you just like do incremental updates and you get to see something immediately. So I was really afraid of hardware for a long time. So I have to share that actually this hardware is actually very easy if you take the right approach. So essentially, I like to do security. Really like to do attacks. I like to attack anything at all. But a few years ago, I created something called USB drive-by. It's pretty simple. This is a teensy microcontroller. Check out my sweet slides. All right, so that's a teensy microcontroller. It's like an Arduino. It's a little more powerful. It has an ARM microcontroller on there. And basically, you can plug it into a computer, and it brings some basic software that does something very simple. It simply emulates a USB keyboard. So it's as if you took a keyboard and just plugged it into your computer. And then it starts typing stuff. Like on a Mac, it'll click Command Space to open Spotlight or Alfred. And then it'll type stuff like terminal. And it will open up your terminal. And then it will start typing stuff in your terminal. It'll put stuff in cron tab. It runs a backdoor. It makes an outbound connection. If you have a firewall running like Little Snitch actually allows you to say, oh, I will allow this by using the keyboard, by hitting tab, allow, always, forever, enter. Puts itself in cron tab, makes outbound connections. So even if you have a firewall or router, it always allows outbound connections, right? They only prevent inbound connections. And then it exits the cron tab, exits the terminal, and you pull it out and you walk away. And I was like, oh, this is really fun. Made it work on Windows. It actually works on Linux. It'll replace your sudo. So next time you do sudo, it'll capture your password and then send it off. But like, I still felt kind of lame because you need the computer to be unlocked, right? At all times, you need to have a computer that is unlocked to be able for this thing to work. Otherwise, if you're locked, you're just at a lock screen and it's just typing all this stuff. It doesn't actually know that it's locked. A keyboard doesn't have information like that about the system. So, I mean, literally over a year or two, I was like, how do I improve this? Is there something cool I can do? And finally, one day, I realized what I could do. Maybe other people would have figured this out in much sooner. And I just want to take a little tangent. A lot of the time I try to understand how can I be more creative? Not like creative like David is super creative. I'm not creative like that, but at least can I think of cool ideas that maybe haven't been thought about or not explored so much. And I'm always like, I read online, what are the best ways to do this? And one is getting a lot of sleep, right? Sometimes exercise, that's supposed to be like, I hate exercise, but you're supposed to do it. Makes you happier. But it was specifically when I was really sleep deprived on a really long flight that I came up with this. So I don't know, I just wanted to like share that with anyone. I was super sleep deprived, and that's when I came up with an idea that took me a year or two to actually come up with. So I thought that was super interesting. Maybe you have had experiences like that. So we're here to talk about not this teensy microcontroller, but instead the Raspberry Pi Zero. So this is the Raspberry Pi Zero connected to like a little USB dongle. It's $5. They're pretty limited in quantity, so it's probably like $15, 3 times the price right now. But it's very cool. It actually runs Linux. So you can actually run Linux on this thing. It has, this one does not have Wi-Fi, but there's a new version called the 0W that has Wi-Fi and Bluetooth. Runs Linux. You can connect to it over serial via USB, and you can kind of do anything you want on Linux. It has a little micro SD card, it has a mini HDMI out, and it has a USB on the go. So you can plug a legit USB into it and then actually connect a USB hub and real USB devices. And while I was on that plane and super sleep deprived, I remembered that when I have my screensaver on, this is my screensaver, it loads Slashdot. It uses the RSS feed and just loads Slashdot so I can just see what's going on. And I thought, all right, if you're using Slashdot, you're using the network, right? You're using the actual network controller on your computer, whether it's Wi-Fi or Ethernet. If that's the case, that means that the network is still working on your computer when it's locked. So if that's the case, can't I like pull out? Let's say it's Ethernet. Can I pull out Ethernet and put in other Ethernet? Well, you can. You can actually do that. And what will happen is your computer will now get onto the new network, onto the new Ethernet. Of course, most devices don't have Ethernet. If you have a Mac, you probably don't have a USB or HDMI or power or headphone jack. But you do have USB-C on the new ones, and you have Thunderbolt, and you do have USB on the old ones. And the cool thing is you can do a lot of things over USB because it's plug and play. So you can actually have Ethernet over USB. Just like you can go out and buy an Ethernet over USB dongle. So you can plug that in and then plug Ethernet in. And the beautiful thing about every computer and every operating system is that as soon as you plug in Ethernet or Ethernet over USB, which is just Ethernet to the computer, to your operating system, it will load that up. And what happens? The first thing it does is it sends a DHCP request. So the interesting thing about the Pi 0 that is not on the Raspberry Pi, not on the 2, not on the 3, but specifically with the Pi 0, is that it specifically talks USB directly from the chip. On the Raspberry Pis, they actually have a separate chip that's for USB, and that actually loses functionality of the CPU. So on this, because you're talking directly with the chip, you normally are loading slaves onto your machine. So you're like plugging into a keyboard into this, and this can read it. But you can actually reverse the role and emulate a slave or USB gadget. So now this can pretend to be a USB device. So you can pretend to be that USB keyboard like we did with the Teensy. The thing with the Teensy is that can only do a keyboard and mouse. This, you can do other interesting things like act like a network controller or act like an Ethernet controller. So in this case, I programmed the Raspberry Pi 0 to pretend to be Ethernet over USB. So now when you plug it into a computer, it starts up an Ethernet device. So let's actually see what happens. I will open up my network so you can see what's happening here. We'll zoom in a little bit. So I'm connected to the Wi-Fi here. And what's happening is the Raspberry Pi is booting up, starting Linux. We'll wait a minute. Once it comes up, it will emulate a network controller, and that should come up without you doing anything. It won't ask you anything, like if anyone has ever plugged any network thing or USB, it won't ask you. And now that's pretty cool, except for there's a big problem. When you're connected to something like Wi-Fi, here you'll see that I'm on Wi-Fi, and that's my #1 priority device. We just saw PoisonTap get detected. Oh, we're connected. Okay. Now, notice the order. Wi-Fi is actually on top. So there's actually a network priority order, and we have routes, right? On every system, we have routes that say, okay, if you're on this network, you're going to send all your traffic here, and if you're on this network, you're going to send your traffic here. And my Wi-Fi has higher priority than PoisonTap. So nothing's actually going to go out PoisonTap. The only thing that will ever go out PoisonTap device is stuff destined to that network. And typically your network is like a subnet. It's like 256 IPs, 255 IPs. So you're not going to get any traffic out unless you're sending something to that like internal IP, like 192.168.0.5 or 10.0.0.1. But when you're DHCP and PoisonTap acts as a DHCP server, something interesting happens in that you get to say how big your LAN is, how big your subnet is. So you can say, oh yeah, I'm only 256 IPs, or you can say I'm the entire internet. And I have higher priority because if you have 2 network devices, you want to always send your internet traffic to the higher priority one. But if there's LAN traffic destined to the other one, you send it to the LAN traffic, even though it's a lower priority interface. So as long as you say, oh yeah, every IP address is on my LAN, then it will go down to the second interface, the PoisonTap device, skip Wi-Fi entirely, and now send all internet traffic into this little guy. Oh no, it disconnected. Okay, so now all your internet traffic is going through here. And the cool thing is your computer can be entirely locked and password protected. It will still do this. So when you leave for lunch at your office and your computer is left there, it's password protected. Well, someone can still come in and plug this in. Now, okay, you're sending a bunch of network traffic, but you're not actually doing anything because no one's on the computer. So you're not doing anything interesting. Who leaves their browser open when they leave for lunch? Not anymore, yeah. Me too. And who's familiar with Ajax? All right.
My hero.
So Ajax does some really cool stuff in the background, and every website ever uses Ajax now because you have to let big advertising companies know what's going on, right? You have to send all that analytics traffic and advertising traffic constantly back and forth. So as your computer is doing that, it's sending Ajax requests back to the internet. So if you were to lock your machine, walk away, and someone connects PoisonTap, all your traffic starts going through here. But there actually is internet traffic because if you have a browser open, there's just stuff going on in the background at all times, right? You can open up your network, blah. And if you just leave any site open, it is going to start doing requests in the background without you doing anything, right? Because it's updating advertising, it's updating analytics, and all sorts of ad traffic. Like I'm not touching it and more stuff is getting sent. That's very cool. So what will happen is it will now send all of these Ajax requests to PoisonTap, which is not a big deal. Except many of these Ajax requests are requesting HTML or JavaScript or JSON-P. And in that case, PoisonTap can actually respond with HTML and JavaScript. So now this device is sending JavaScript back into the websites that you have open on your computer. So what can you do now? You can execute JavaScript. So once you can execute JavaScript, what can you do? You can actually start doing some cool stuff. The first thing is, as it's making these requests, it's also sending your cookies because your cookies are in all the headers. Now, this will, let me state, this will not work on HTTPS sites. Well, it will work on some. So I'll go into that. But essentially what's happening is as you're sending all of these requests, as long as they're HTTP, they will hit this and you will send your cookies along. As this is now grabbing all of your cookies and storing it locally. What you can do next is it's then sending code back to your browser. And that code essentially takes the Alexa top million websites and loads iframes, hidden iframes for every single one. So if you only had one website open, you've now just opened the top Alexa million websites, and you're now sending all of those HTTP requests into PoisonTap. Simultaneously, it's sending back that JavaScript. It's grabbing all of your cookies. At this point, you've collected cookies for a bunch of websites. Now, thanks to Snowden, we know that a lot of people are sniffing unencrypted traffic. So a lot of people now use HTTPS by default. However, many people still don't set their cookies to secure. So your cookies will actually still work on the HTTP version. Now, many people think, well, the HTTP version of our website will never load because we only use HTTPS until your network is hijacked, at which point it's sending all of its cookies over HTTP because I said HTTP is okay. I'm running on port 80. I'm not doing any redirect. So you are sending those cookies over HTTP. So if you run a website, always make sure your cookies are set to secure. Additionally, use HSTS. That's HTTP strict transport security. That will cache in your browser and say, oh, if I have been to this website before and it's supposed to be HTTPS SSL only, it will only ever use that for the future until that cache is removed. So that's really fun. Now we've gotten some cool stuff here. We've talked about how we've gotten essentially hijacked this network traffic. This is your router. It's, I guess, wrong image, I guess. So let me just grab some notes here. Once you've actually, now that we have all these cookies, you can essentially pull this out and walk away, which is pretty nice. You have all these cookies. The computer's still locked. When you walk away, they won't even notice. They won't know that anything has happened. But it would be cool to do more. So there's something called DNS pinning or DNS rebinding. So one other thing that PoisonTap does is it auto-detects what network you're on. So it'll actually figure out what subnet you're using. And then it will reach out to your router. So it'll make a request to your router, which will be on, let's say, 192.168.0.1. But if we remember from our routes, we can't actually take over a higher priority route. Like if you're on Wi-Fi and you're 192.168.0.1 there, that's your gateway, you can't take that over from the PoisonTap device. But we can set up a special DNS server. So I run Samy.pl, it's my website. And I've set up a special DNS server called ip.samy.pl. So if you type in 192.168.0.1.ip.samy.pl, that'll load 192.168.0.1, your local IP address, unless you're using PoisonTap. At that point, that host name, because all DNS requests go through here, will load the IP address of PoisonTap. So now it will hit your router's host name, which is 192.168.0.1.ip.samy.pl, and send a cache backdoor, which uses a really cool technology called WebSockets. I love WebSockets. Then that WebSocket makes an outbound request to my public server, and I can now inject code into your running system. And because we've made 1 million requests to the top Alexa 1 million websites, each of those is caching this WebSocket backdoor. And as long as you have a backdoor on every single one, you can then run code on every single domain within that origin and within that context, so that you can do AJAX, you can do cookies, you can do gets, you can do posts, and you can essentially control that domain. Now, once you pull this out and you walk away, I can then go home, go on my server, and I can connect back to you because you're actually making a WebSocket out to my server. And the one last piece is that because I've loaded something 192.168.0.1.ip.samy.pl, which is a host name which runs the backdoor, you can basically hit that again, refresh that page, and because all of these pages are cached indefinitely on your computer, it will load that backdoor on that domain. But that domain now points to your IP address of your router, which means the attacker now has access to your router. At that point, they can change your DNS server, DNS host name, and do a lot of other cool stuff. Actually, there's Matt Austin. He came up with a really cool attack for this. One of the things is browsers started preventing the DNS pinning, essentially using a host name and then changing the IP address later so you can attack a different website. So Matt figured out that if you actually load a ton of websites, like 1 million of them, it will remove that cache because you can only store so much memory in your browser. Matt's also working on another thing for this, which I'm super excited about. Can I talk about it? Oh yeah. So Matt Austin is actually working on some really cool, some really cool JavaScript attack where he can essentially also autofill. So who uses autofill? Don't use autofill, right? Because we're keeping all of these passwords that even if they're secure on the cloud or they're encrypted and someone doesn't have the password, if something like this gets run on your computer, as long as your autofill software is okay if it asks you for a password, if it asks you for a password. If it just fills it in, well, Matt's making an attack where it will fill it in for you in the background using a device like this. So it's now filling out all of your passwords for all of the websites and being stored on this device. I have found a really cool way to stop this attack, and I'd love to hear any additions or features. So cement. Adding cement to your USB, I found, has prevented this attack. That's basically the best thing. Now I know a lot of you probably work on a lot of servers, so the things I'd like to say, use HSTS. That's HTTP Strict Transport Security. That will solve a ton of stuff. Make sure you're using TLS, obviously, right? Make sure that your website has HTTPS. Ensure the secure flag is enabled on your website because there are lots of big websites that use HTTPS exclusively but don't have the secure flag, which means your cookies will get sent to the HTTP version. It's very easy to hijack networks. Let's actually try this. So if you're actually to go to a website, let's see here.
Don't mess with NFL. We're fixing it in 2 weeks.
What's that?
We're fixing it soon.
Oh, is there something getting fixed?
Yeah. We're blasting new home fix.
Oh, really? Oh, is something broken with it? No, I'm serious. I'm seriously asking.
Not in 2 weeks, apparently.
Oh yeah. So something like any website would probably load a ton of stuff in the background and then load PoisonTap. This is a really cool animation from Aura on CodePen. I've tried to reach out to Aura, him or her, I don't know this person, to like say kudos for like this amazing canvas animation. But this page will also show you everything that's happening. So you see all the different websites that are getting cached and being attacked in the background. While it's also installing backdoors on every single website, they're all cached. You can now do cross-domain requests with the user's cookies. Yeah, it's kind of crazy. So adding cement, that's always good. This kind of sucks. Close your browser every time you walk away from your machine. I don't want to do that though, right? So I still don't do that. If you're using a Mac, use File Vault, because what you can actually do is you can put your computer to sleep, and as long as it requires your password when you come back, the sleep will actually prevent anyone from doing anything. Your browser won't be running essentially while it's in sleep mode, even if they try to unlock it. So I'd say keep your computers in sleep when you leave. I would also ask if you have any additions, please add some features. This now is cross-platform. It runs on Windows, Mac, Linux. If you have a way to stop it, please implement that as well. I think we should be doing both. I think that's about it. I just wanted to sort of share this project. Yeah.
Wow. Scary stuff, but also super interesting. I felt like I not only learned about PoisonTap, but I learned about how networks work and kind of like a lot of the research that you have to do to be able to execute these attacks. So we're going to take a few questions, if you don't mind.
Please.
Does anybody have any questions?
Hey,
First off, Samy, you're mean, real mean.
I love you.
So you talked about how to prevent it, obviously, totally seriously. What happens if you've already attacked my computer, which hopefully you haven't?
Okay.
What do I do to get this off of my computer to close the backup?
No, that's a great question. So first, delete your clear your cache, because if you see the URLs, I'll put this in. So http://twitter.com/poisontap is a cached backdoor that makes a WebSocket out to my machine, and then from there it allows me to traverse any other domain, because then I can. From that WebSocket, I can send JavaScript code back, and then I can create an iframe to another website like msn.com/poisontap, because that's running my code. I can essentially, hop origins. So you first want to delete your cache. A second thing is you don't know if I've actually made changes to your router. So assuming so make sure that you don't use the default passwords on your router. Right? You have a router at home, you're like, oh, who's ever going to come into my house? I'm not going to give out my Wi-Fi password, and I'm not going to have people coming into my house plugging Ethernet, into my router, so why should I need to change the password? This is why. Don't use the default router password, because someone will be able to come in and change it. They could upload new firmware, right? They could then you're just kind of screwed. It's an unlikely scenario. I think and then you would have to log out of all the websites because someone already took your cookies, right? So you'd have to log out of all your websites and hope that they didn't make any changes. Yeah.
You're real mean.
I think the interesting thing, and the reason I was interested in this, is like we've been using USB forever, and IP and DHCP has been around forever, right? Since we've had internet. And yet this is a problem that still exists today. And like, there's no way to just go in and say, no, don't allow random network devices to get turned up on my computer. This hasn't been fixed. It's kind of crazy. Yes.
Question. So if you have X-frame origins to disable iframe, then this website won't be available.
That's a really good question.
Yeah.
So PoisonTap actually evades X-frame origin. And that's because the X-frame origin header is sent by the real server, not by the PoisonTap server. So when this gets hit, this says X-frame origins, no, and then allows loading X-frame origin, allows iframes. Additionally, from then on, because that's cached indefinitely, when let's say I'm attacking you remotely, I then load that, let's say msn.com/poisontap, which is cached, including cached headers, including no X-frame origins, hence allowing me to do iframes indefinitely. Yeah.
Could this tie into EverCookie?
I'm sorry?
Could this tie into EverCookie?
Oh, could this tie into EverCookie? EverCookie is a project I did some years ago, which just creates a persistent persistent cookie. So it uses standard cookies, but it also it stores the cookie in your history, in your cache, in local stored objects in Flash and Silverlight and Java. uses Java exploit, uses local storage, global storage, e-tags, user data. Matt Austin actually came up with storing the data in cached PNG images and then retrieving it with HTML5. So it's a very precise. And then if you delete 99% of them there's still one, it respawns in all of them.
Dude, it's crazy.
So yeah, you could probably you could actually load ever cookies on these, right, and add just additional persistent tracking. Yeah, that's a good question. I haven't thought about it.
It's your work.
On clearing it up, how do you prevent DNS rebinding, or how do you clear up DNS rebinding?
How do you clear it up?
Yeah. So you've messed with my DNS cache.
Oh,
So as part of clearing up what Sammy's hacked, is it cached after a restart of the browser?
that's
DNS?
a good question. I actually don't know.
Or is
I
it
haven't
local
tested
DNS
that.
cache?
And also, let's hope this works. Let's see if it.
Also, do you target CDNs so that you get really cross?
Oh yeah, so there's another feature of PoisonTap. Good question. There's the feature of PoisonTap is who uses like Google CDN for jQuery and loading things like that. So it also, sorry Google, I've taken all of the Google CDN URLs and a couple other CDNs for like jQuery and Angular and all the common libraries, and I replaced them with a backdoor. So now I don't just entirely replace them. I only prepend the backdoor. So the backdoor. So like let's say you have a website and it's not in the top million Alexa websites, right? You're 1,000,002, but you're using the jQuery CDN. So what I do is during these requests that are occurring, it's also making requests to all of those URLs. And what I've done is all of them are stored on PoisonTap, but with the simple WebSocket backdoor followed by all the real code. So your website will still work perfectly, right? Your jQuery little animations will come up and down and hide and look cute. I love that stuff. It will also make the WebSocket out back to my server, even if you're not in that top million, as long as you're using one of these CDNs. Yeah, good question. So also I provided this. I provided a DNS server anyone can use where you can actually do IP pinning. So if you wanted to perform your own IP pinning attacks and don't know how to set up like a custom DNS server, this has a really cool feature where essentially you can, 1.2.3.4 was set to 1.0.0.1 a moment ago, but is now set to 1.2.3.4. And you can actually direct to where you want it to go by making a DNS query. So if you say query, let's say 5.6.7.8. Is it pin.ip.samypl? Do you remember, Matt? It's on my website. It's on samy.pl. My website describes how to use this DNS server, but you can actually do a lot of really cool attacks with DNS rebinding, where you've temporarily pointed someone else's address to your website, so you can temporarily control that website and then cache data. And then when it goes back, you're now running in the user's browser on the real website.
We're over here.
Oh.
What's your goal for creating this project?
I used to be like, oh, well, I'm a good guy. I want to show people all the wrong things. But honestly, it's just fun. I have to be totally honest. It's really fun. It's fun. This kind of stuff to me, it's a puzzle. And we've all done puzzles, right? When we were kids, we made puzzles out of a book. It's really fun to solve puzzles. But when you're hacking something, I feel like you're solving a puzzle that was never intended to be solved. It was like someone created a maze and they blocked off all the ends and you can still get out. It's even more exciting than when you do it. But I'm not a bad person, I don't think. So I think for stuff like this, I release it because I think it's really interesting to demonstrate. How do you know no one else has been doing this for the past 15 years, right? I think we should stop this. I'm not going to go put too much effort in stopping it myself. I'm interested in other things. I'm interested in hardware. Another thing I want to share with the js.la is that JavaScript is awesome. I've used JavaScript for a long time. Before Node, I was using Rhino. So I took Rhino from Mozilla Firefox, which is their C-based JavaScript engine, and I use that on my backend so that I can run the same JavaScript code on the front end and the back end. And then Node came out, and that was really exciting. But if you want to get into hardware and you're afraid of Arduino, Raspberry Pi, Get an Arduino, get a Raspberry Pi. They're very easy to use. I'd say Arduino you can get up in 5 minutes. If you're interested in hardware, you can get lights blinking in 5 minutes. And the cool thing that I didn't know when getting into it is that you write code. You're actually writing code. Now Arduino is C or C++, but there's something called Espruino. And Espruino is a JavaScript interpreter running on a microcontroller. So you can actually get something like puck.js and start writing JavaScript code in hardware and blinking lights and a couple of lines of JavaScript code. So for anyone who's thinking about it, like sees it all the time, it took me many years before I jumped in because I was terrified after I read this stupid electronics book. It was a terrible decision to read that. But going into the Arduino, I should have just searched Arduino.
Browsers are starting to support HTTP public key pinning. Does that help
cool.
at all with any of this?
That's a good question. No, HST it's a good thing. Public key pinning. So public key pinning allows you essentially to say, all right, this is you should only be using these 3 keys for my website if you happen to see the Hong Kong Post Office, which actually is a certificate authority in all of your browsers. If the Hong Kong Post Office says, oh, I have a SSL cert for google.com, don't trust it because I've pinned these other certificates. That is useful, but specifically only when you're on a TLS connection. So if you're able to force the user to downgrade to HTTP, then it will have no effect. However, in conjunction with HSTS, that will then force you to be on TLS. Key pinning, the only way key pinning would be it doesn't hurt. The only way it would be beneficial here is if I also happen to hack into a CA and I also could issue certs so that I could do TLS through PoisonTap with this bad legit root cert that I'd hacked. Then key pinning would be beneficial. Has anyone looked at the certificate chain in your browsers? Do you trust all these countries that I've never heard of? I don't know where they are on a map. Granted, I don't know where a lot of things are on a map.
All right, last question.
Well, since this is the last question, I want to first thank you for sharing your experiences with us.
Oh, thank you.
Very interesting.
Awesome, thanks,
I
Kat.
have a comment and a question.
Sure.
Did I hear correctly that you had trouble breaking into a couple of physical doors at Google's
I was
that?
embarrassed.
I would have
And I
expected
couldn't, you can't social engineer it, right? I think social engineering is super interesting, but I don't like it because I like to be trusted, right? I want people to trust me. I try to be trustworthy and very transparent. I tell you when I'm breaking into your computer. So I don't like deception.
I would have kind of expected you to break into it in 20 seconds.
And I'm a guest here, yeah, so I wouldn't do that.
But on a more serious note, I'm wondering if you are putting together some guidelines and techniques to fight all these hackers and ransomware and things that are going around with the type of expertise that you have now and the experience that you have.
Oh, that's a good question. I really should spend some time doing that. If I were to say anything that you should do, I would say, number one, keep everything upgraded. Just always upgrade everything. It's a pain, but it's getting easier. Number two, upgrade. There are attack vectors for auto upgrades. I would rather have that. Attack vector than just having old, outdated software. And number two, use different passwords on every website. And it's okay to use a password manager as long as that password manager requires you to enter a password to use the password manager. Those two things will stop 99% of attacks. So I think that's the simple thing that I don't like being inconvenienced with a lot of security stuff. So I run all sorts of insecure software. And I'm very insecure myself because I do like convenience. But those will stop most things.
All right, let's give it up.
All right, thank you. Awesome. Thanks, man.